Welcome to another computer science video. So we should be live if you're watching this right now. So this is a live stream, but again, I will upload this after the live stream if you're interested. So this is my first video with the face cam. Hopefully you will enjoy these types of video. Hopefully you'll connect more with these types of videos. Um, so yeah, anyway, today we are going to be having a look at computer science, and we're going to try to cover the entire syllabus. So there's about 8 chapters. Okay, so we're going to be trying to cover all the 8 chapters for the theory segment, or the theory part. Okay, so here I have the official Cambridge IGCSE textbook, which I've linked down in the description, and I've called it notes, so you can go and check that out right now. At the same time, if you've already revised whatever I'm going to be going through this video, there's some past paper questions, past paper question videos where I go over all those questions. You can have a look at that, so you can just improve your accuracy and practice more and more if you're confident with what you've learned. But if you have not, again, you can finish this entire live stream and then go and try to solve these past paper questions for extra practice. Anyway, so we're going to start, and we're going to start with the basic. Now, I've done many live streams covering many other topics that I'm going to be covering up in this live stream, but I thought we start fresh and do everything. So as you guys can see here, we have section 1. I'm going to be doing section 1 in this live stream. We have chapter 1, chapter 2, chapter 3, chapter 4, 5, 6, and 7, as you guys can see, and finally we'll have 8. Now, in the future, I will be maybe making a practical video or the segment where we talk about the computer science in terms of practical, where we have pseudocode, we have Python code, and a lot of stuff, flowcharts and everything related to that, truth tables, query tables, and everything related to that. So maybe in the future I will be making a video focusing all on just that. But in today's live stream, we're going to have a look at the entire paper 1. So paper 1 initially is only theory. Okay, so where we have only theory, 75 marks, only theory. So that's what I'm going to be covering in today's live stream. So this is great revision for your upcoming exams. Okay, so we're going to start with the binary systems and hexadecimal systems. Okay, so here are the 8 chapters for the section 1. So we're going to be covering all these chapters in today's video. So stay tuned for that. We're also going to do some examples and work our way up to chapter 8 and hopefully finish the entire paper 1 content. Okay, so let's begin, and let's start with the first chapter, binary systems and hexadecimal. So I'm going to take my pen tool out, and we'll be also reading and telling you some information about this. Now, the first thing we are going to be having a look at is binary systems and hexadecimal. So initially, what this basically means that a binary system is basically used in the computer. So is the hexadecimal. So in chapter 1, we're having a look at what the computer understands. Okay, and we use a language called binary systems. Now, before even we go to the computer language, let's have a look at our own language. Okay, so we say number system. Let's have a look at our number system, because when we're looking at binary systems, hexadecimal systems, we are only dealing with the numbers. Okay, no letters, nothing like that. Of course, in hexadecimal, we will come to letters, but they are equally they can be changed to numbers. Okay, like later on you get to know hexadecimal A basically means 10. Okay, so technically they are basically numbers. So we say these are called number-based systems. Okay, and there are different types of number-based systems, and we're going to be having a look at 3 number-based systems in chapter 1. Now, if you don't understand what I'm talking about, you will in just a bit. I will be explaining the number-based systems, step by step. So let's go back to where I was talking about. So I was basically saying our own number system. Okay, our own number system, we say in computer science terms, it is called denary number system. Okay, so it's called the denary number system. Now, if you have noticed, okay, and you should know this, that in our number system, we only have about 10 numbers. We have only 10 numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Sorry, till 9 only. After that, all the numbers after that is simply comprising between these 10 numbers. Okay, that means, for example, we have 0, 1, 2, 3. Okay, to construct 22, I'll need 2 and 2, which I talked about in the 10 numbers. So the denary system is the number system we use. Okay, the computer does not use the same system. Okay, later on we'll get to know why. Okay, but in simple terms, what this textbook gives an example of is a computer is comprised with so many switches. Okay, and in simple terms we can say, okay, maybe let's assign one switch a number. Okay, so for example, to switch on something, we can say it's represented by 1, and to switch off something, it's represented by 0. Now, let's have a look at the number-based systems. And again, if you don't understand yet, don't worry, I will explain everything just in a moment. Okay, so here comes the actual part that you need to know: binary systems and hexadecimal systems. So we start with binary systems. Okay, binary systems have only two numbers. Okay, there are only two possible numbers that it can have. The way in denary we had only 10 numbers, 0 to 9. So with the binary system we have two numbers, and those two numbers are 0 and 1. Now this textbook or this notes is giving an example that 1 will be maybe the position on and 0 will be the position off. Later on, again, as we will develop our skills, we'll get to know about something called registers. Okay, and we're going to have a look at all the uses of binary system, uses of hexadecimal system, everything related to this. So as an introduction, I want to tell you about binary systems and hexadecimal. So this is chapter 1, and let's have a look at this. Okay, so here it is, the binary system. Okay, so we know denary system 0 to 9. Okay, hopefully I explained that well. Hopefully you understand that. Okay, that means that in our number system we have only 10 digits, 0 to 9. Okay, 0 to 9, all are those digits. Okay, after that we're just basically using them again and again. So in relation to that, we have the binary system. Okay, the binary system is comprised of only two numbers. Okay, the two numbers 0 and 1. Okay, so we say the binary system is based on a number 2. Okay, the way the denary number system is based on the number 10. Okay, so the binary system is base 2. Okay, we say that it has only two possible values, therefore it has a base 2. Okay, so let's give an example of how a binary number would look like. Okay, so right here, if you guys can see, this is how a binary number would look like. As you can see, there are only two numbers, 0 or 1. So there are only two possible values that can be, used, either 0 or 1. Okay, so hopefully you understand, the difference between binary and denary. Okay, so an example of denary would be 56. Okay, just our number system. Any number in our number system is denary. So for binary, it will be 11011110. Later on, we will get to know why we do this, uses of this, so don't worry about that right now. So, in simple terms, even, for the sake of just explaining it right now, the binary system is basically used so that we can communicate with the computer. Okay, because the computer cannot understand denary. Okay. Again, I'll also tell you about hexadecimal and its uses. Okay, so let's start with the first one, converting from binary to denary. Okay, remember binary has only two values, while denary has 0 to 9. Okay, so let's see how we can convert from binary to denary. Okay, and this is a very common exam question, and you will never miss number system conversions, so you better understand this right now. Okay, so the best way to explain something is by doing an example. So I'm going to be doing an example right now. Okay, so let's do an example. So for example, I have let's use their example. Okay, I'm going to try get an example so we can use. Now the method I use is method 1, and I'll be explaining method 1 now. Also method 2 I'll briefly go over it, but I prefer choosing method 1, but some people prefer method 2. I find that method too, sometimes you can find, or you can make mistakes. But method one, is sort of more, reliable, according to me. But again, you can see for yourself and decide which method works for you. So there are two methods to convert from uh, denary to binary. Oh, sorry, I missed binary to denary. Okay, simple. Okay, so let's have a look at binary to denary. Okay, so I'm going to use a activity 1.1a. I'm going to do a. So I'm going to write these numbers once again like that. 1, 1, 0, 0, 1, 1. Okay, this is an example of a binary digit. Okay, hopefully you guys can see. Let me zoom in so you can see better. Okay, hopefully you guys can see. Okay, so here we have the value. Okay, 0, 0, 1, 1, 0, 0, 1, 1. This is my binary digit. Okay, this is my binary digit, and I want to convert it into denary digits. Okay, and denary digits is our number system. So how can we do this? Okay, so the first step you will want to do is just simply put 2 over each number. Okay, and just simply follow this step. Okay, put 2 on top of each number. Okay, once when you've put 2 on top of each number, from the right hand side to the left hand side, start with 0 to the power 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 6, and 7. Now in computer science, for these number systems, every time you have 0, okay? So every time, okay, I'm going to choose another color, or let me highlight, or sorry, let me choose another color. Okay. Every time, okay, every time you see 0, okay, every time you see 0, cancel it. See 0, cancel it. You see another 0, cancel it, and cancel it until you're left with only ones. Then what you simply do is the number above the 1, like for example 2 to the power 0, okay, 2 to the power 0, 2 to the power 1, 2 to the power 4, and 2 to the power 5. Okay, 2 to the power 0, anything to the power 0 is 1. Okay, 2 to the power 1 is 2. Okay, and you can see I'm only looking at the values above 1. Okay, so I'll finish this. For the next one right here, I'm doing plus 2 to the power 4. Okay, now usually in a computer science exam, you're not allowed to, have calculators, so you'll have to do this all mentally, and then you add 2 to the power 5. Okay, so 1 plus 2 plus 2 to the power 4. So what simply you do is 1 plus 2 plus, you have to find 2 to the power 4. Okay, and with this table right here, you can memorize it: 1, 2, 4, 8, 16, 32, 64, 128. You can see 2 to the power 4 is 16, so I'm going to add 16, and 2 to the power 5 should be 32. Okay, so 32. Now I simply add the values, and you'll have to use some, the old ways. You cannot rely on your calculators, so you have to, do it the long way. Okay, so 48. So the answer will be 51. Okay, and 51 is our number system. We say 51, we say 1, 2, 3. 51 is our language, our number system. So that is how you convert binary to denary. Okay, hopefully you understood that. You can play that again so that you understand. And this applies for any binary to denary. Finally, let's move on to denary to binary. So now, how can I move from 51 to the following number on top? Okay, now a method I like using is similar to what we just did. Okay, what you simply do is write 2 to the power 0, 2 to the power 1, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6. And you can memorize what this means. Like 2 to the power 0, I'll always know it's 1. This is 2. This is 4. This is okay. Sorry, I missed 2 right here. So sorry. I'm gonna erase it. Now you can remember these numbers in order. Okay, and you can remember these orders: 1, 2, 4, 8, 16, 32, 64, 128, 256, 500 and something. Okay. Simply what I'm doing is 2 to the power 0, 1, 2, like that going on. Okay. This is the same numbers that are here. Same numbers. Okay. So what I'm basically doing is now I need to convert from from denary to binary. And what I do is I make combinations. Okay? This method can take some time, but I show you it's the best method. Okay. For example, I want 107 to binary. Okay, 107 to binary. So the first thing I'll do, okay, let's add 64. Okay, and let's add 32. So 64 plus 32. Okay, this will be 96. Not yet reached 107. 96, let's add maybe 8. Okay, let's add 8. So 96 plus 8. That should be about 104. But not yet reached 107. We need how much? 3 more. So I can do 2 and 1. Okay, which is going to be 3. And that will be 107. So what I'm simply doing, I've picked which numbers? I've picked 64. I've picked 32. Hopefully you can see this. I've picked 64. I've picked 32. I've picked 8. I've picked 1. And I've picked 2. So everywhere whatever numbers I've picked, I'm going to put a 1 below it. Okay, because remember, we only add the ones with 1. Okay, so I've picked 64, so that'll be 1. I've picked 32, that'll be 1. I've not picked 16, so it'll be 0. I've picked 8, that'll be 1. 4, 0, this. This will be the binary number. And if you've noticed, this number that I've just written is the same thing as this number right here. Of course, there's a 0 in here, but you can just put the 0. It wouldn't matter because we don't count it. So this will still be correct. Okay, so that's how you convert from the denary value to the binary value. Okay, now let's have let me introduce you to the hexadecimal values. Okay, so finally let's have a look at hexadecimal values. Okay, but before having a look at hexadecimal values, let's have a look at measurement of the computer size, okay, or the computer system. Now, in computers, we have size, of course, okay, because nothing, all devices have size, okay, measurement, okay. So what this basically means that even if you have, or if you're watching this video on your phone, you know that, for example, your phone has a capacity of 64 GB. That's the max. And then the phone gets filled up. So using that same theory, a computer also has that. Any device actually has that. Okay, so in computer science, you need to know the memory size. You need to know the memory size of the computer system. Okay, so we start with kilobyte. As you can see, 1 kilobyte is equal to 2 to the power 10, bits. We have a megabyte, we have a gigabyte, terabyte, and lastly, a petabyte. Okay, so in computer science, you need to just know these, is it 5? Yeah, you need to know these 5: kilobyte, megabyte, terabyte, and petabyte. Okay, you need to know those 5. Okay, so there can be a question, as you can see right here. I'm gonna highlight it so you can have a look at it. So let me just highlight it. It says that to give an idea of these skills, a typical data transfer rate using the internet is 32 megabits, which is 4 MB per second. Okay, and then it says, so 40 MB files will take 10 seconds to transfer. This statement right here tells you about what we're going to be talking about. Okay, this is sort of an example to a question. Okay, so for example, it tells you these are usually very 1-mark questions. Very easy questions. Okay, you need to just think and you'll get the answer. Okay, so here we're saying that a typical data transfer rate of the internet is 32 MB. Okay, megabits, MB. Okay, typical transfer rate is 32 megabits, and it's saying that is 4 MB per second. Then it asks you, how much will a 40 MB file take you? Remember, 4 MB per second, so you simply do 40 divided by 4 to give you the number of seconds it would take to transfer the entire file. Very simple math, and most likely you all are doing maths, so this shouldn't be a problem. Okay, so the answer would be 10 seconds to transfer. Very simple questions, and you just need to know those five, which is kilobyte, megabyte, gigabyte, terabyte, and petabyte. Okay, hopefully you understood that. Let's move on to finally have a look at some uses of binaries. Okay, here is now where we further develop on what we were talking about before. Okay, so previously I was talking about the binary digit, the binary value, and why do we need binary value? Okay, that's a big question. Why do we need binary value? Now, the binary system can be used in registers, as I was previously mentioning. As you can say, in chapter 4, we're going to be having a look at more, going to have a focus on registers just as itself. So we're going to have a look at that. But simply, registers are a group of bits that are simply told to do something, and they perform it. And in those registers, we use the binary values. We use the binary system, the binary digits. Okay. Now, so we use registers, and for example, I can give you an example. 1 is for on, 0 is for off. Okay, very, very simple example. Okay, so that's just a simple example, and questions are usually structured like that. For example, they give you sort of a diagram like this one right here. It says, there's a wheel that rotates whenever it's 1 or 0, and you have to make a binary value digit or whatever. Okay, so every time it's 1, it means that it rotates. Every time it's 0, it doesn't rotate, something like that. And it's quite simple. This should be a very easy question. Again, if you want to practice on these types of questions, I've had past paper questions, and you can also request for a past paper question that you want to be solved. Just down in the comments or now in the live stream, you can do that. Okay, so let's move on now. Finally, let's move on, and let's have a look at the hexadecimal system. Okay, because we had to look at the binary system. Now let's have a look at the hexadecimal system. Okay, so the hexadecimal system, what is the hexadecimal system? Okay, the hexadecimal system is like, kind of related to binary system. So then you would ask yourself, why do we need to know it then? Okay, so I'll tell you this. First of all, hexadecimal systems are much easier to use compared to binary systems. Okay, because if you've noticed, all those digits 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, it's complicated. Okay, and a human would not remember it, of course. Okay, because right now the example, would you remember what I did? Probably won't. Okay, because there's so many values, even though they're only 2 numbers, there's so many, it is very hard to work with. That means that if I even make one number as a mistake when inputting, I wouldn't be able to find the mistake. And therefore, we come to the fact of hexadecimal system, which is a much easier number system that we can work with. Okay, so let's have a look at the hexadecimal system. Okay, let's have a look at the hexadecimal system. So the hexadecimal system is base 16. Okay, we had the binary system with the base of 2. We have the denary system with the base of 10, which is our number system. And now we have the hexadecimal system, which is a base of 16. Okay, we're a base of 16. So what are these 16 numbers then? Okay, and here is the table that you will be needing. Okay, so as you can see, here's the table, and you need to remember this table. Okay, so the table starts with the binary value. Okay, you can memorize the binary value, but I'll tell you an easier way to memorize this later on when we're having a look at some conversions from hexadecimal to binary, binary to hexadecimal, and so on and so forth. So let's start with the hexadecimal value 0. Okay, denary value will be 0. Hexadecimal value 1 will be 1. Okay, so it'll be all the same till 9, but what changes is when it reaches 9. After 9, we don't write 10, we write A. Okay, so it'll be A, B, C, D, E, F. Okay, so if I zoom out, you should see the whole table for yourself. That is the whole table. Okay, so you can start. We start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have A, B, C, D, E, and F. Okay, A being 10, B being 11, C 12, D13, E14, and F15. Okay, quite simple, very easy to memorize. So finally, let's have a look at some conversions. Okay, let's start with binary to hexadecimal. Okay, so we're starting with binary to hexadecimal and from hexadecimal to binary. So let's start with the first one, from binary to hexadecimal. So here are the steps. You're given a binary, you need to convert it to hexadecimal. What do we do? Okay, so I'm going to rewrite this once again. So I'm going to write this binary value 0, 1, 0, 1, 1. How many ones are there? 1, 2, 3, 4, 5, 3, 4, 1. And there are 4 zeros. Yeah, 4 zeros. So right here is my binary value, and I need to convert it into hexadecimal. What am I going to be doing? The first thing I'm going to be doing is splitting these numbers into 4. So 1, 2, 3, 4, boom. 1, 2, 3, 4, boom. Okay, I've done that. Quite simple. No one should be confused at this point. Then we move on and put 2 on top of each number. Sorry, not 2. You put these numbers 1, 2, 4, 8. The same for the next one. 1, 2, 4, 8, and the next one 1, 2, 4, and 8. Okay, so I've repeated it for the 3 segments: 1, 2, 4, 8, 1, 2, 4, 8, 1, 2, 4, 8. I need to convert this into, remember, hexadecimal. How do I convert it to hexadecimal? Now, a hexadecimal value looks like this, BE1, for example, and hopefully we should derive to that. The next thing, again, remember the principle. Whenever there's 0, cancel it. Okay, so whenever it's 0, cancel it. This only works with number systems, so please don't cancel 0 and other stuff, okay? Only works with number systems. So 0, cancel it, 0, cancel it, 0, cancel it, and then 0, cancel it. Now, we simply just have to add the numbers. So I'm going to write in black, okay? So right here, we have only one number left, is 1. Okay, the next one right here, we have 2 plus 4 plus 8, which is 8 plus 2, 10, 14. And here is 3 plus 8, which is 11, right? Now, this is not hexadecimal, because remember, hexadecimal 11, there's nothing like 11, there's nothing like 14. So remember, with our table, 11 is B, so B, 14 is E, and then 1 remains 1. So this will therefore be our answer. Very simple, very easy. Okay, so that's how you convert from binary to hexadecimal. Now, how do I convert from hexadecimal to binary? Same thing. You divide the hexadecimal code and you convert it into binary. For example, we have the example 45A. You split this into 3 parts. Okay, A. Okay, then write 1, 2, 4, 8, and you need to make a combination that will give you A, which is 10. So remember, 2 plus 8, so 1 on below 2, 1 below 8, 0, 0. Okay, so this will be the first segment of A, and you can see right here that is correct. And then you do the same for the others. I'll just now move on. Quite simple. If you don't understand, I've made an entire video on this. So if you want to have a, if you're confused in any of these topics that I will be having a look at in the live stream, again, anytime in the comment section, you can ask for some help. And also you can watch my other videos on the same topics. And I believe the first video I ever made was on the number system. So you can have a go and have a look at the following. Okay, but again, this is quite simple, so you should understand it very quickly. Okay, let's move on to converting from hexadecimal to denary, and then again denary to hexadecimal. So let's start with hexadecimal to denary. How do I convert a figure of 45A into our number system? Now, again, you need to remember these numbers: 1, 16, 2, 56. And usually in the IGCSEs, you are usually only given about 3 values for the hexadecimal. Very rarely would you ever get 4 digits in hexadecimal. If you do, it's quite simple and very easy numbers, maybe not that big numbers, because again, calculators are not allowed, so they minimize in the work that you do, so you don't waste time again. Okay, so in this question right here, we have 45a. What you simply do is a times 1, which is 10 times 1. 5, you do 5 times 16, and then 256, so you do 4 times 256, and then you just add all of them up, and you'll get your ternary value. Very simple. So you simply just multiply it with the numbers I gave you, 160 to 56. Very simple. How do you convert from denary to hexadecimal? You can divide by 16. Okay, the way for binary, if you want to convert from denary to binary, you can divide by 2 and the remainder on the side. You can do the same thing for this, but this time you divide by 16. Or what you can do is just align 1, 16, 256, so on like that, so that you can get your number. I like the method 1, what you can do. If you don't understand, again, pause the video at any time. You can read these notes, and also down in the description I've been giving you the notes, so you can have a look at that too. But again, this should be quite simple. So let's move on. And now finally have a look at some uses of hexadecimal. So uses of hexadecimal. Let's have a look at some uses of hexadecimal. The first use is memory dumps. Okay, and sometimes you ask this question, so it's important that you know it. So we have the first one, memory dumps. Memory dumps is simply like a list of all numbers. Okay, and this happens, to memory, simple memory. Okay, it just means memory. For example, if I do something to a printer, if I tell it to do something, the memory stored will be stored in terms of hexadecimal in memory dumps. It's called memory dumps. But very rarely do you ask what memory dumps are, so it's not a must to know that. All you need to know is that a use of hexadecimal is a memory dump. The next use is the HTML, and I think you've heard of this quite often. A very popular term that's used. HTML, hypertext markup language, is also written in hexadecimal, and this is not a programming language, but it is a markup language, and is used for presentation and design, I believe, which is the same thing actually. So it's basically used for the presentation of a website. Okay, so presentation of a website, and in this we have colors. So part of hypertext markup language, we have colors, which is RGB. And if you have noticed, if you do HTML, if you know HTML, you know these digits right here, this one, FF00, you know that is written in hexadecimal. Okay, so you can see like this would represent red, green, blue, and so on and so forth. We then have media access control, and this is often asked. So media access control is simply a unique address or a unique number that is used to identify a device on the internet. The MAC address refers to the network interface card, which is the NIC, which is part of the device. Okay, so the MAC address is usually made up of 48 bits to about 64 bits, and has about, I believe, the first segment or the first half is for the manufacturer, and the second half is for the serial number of the device. Okay, so you can, sometimes they ask you, okay, what is MAC address? So the marks you would get, first of all, maybe it's 4 marks or 3 marks. The first one you would say media access control. Already that would give you a mark, because you're simply saying that that's what it means. Media access control, you can say it's a unique number that is used to identify a device. You get another mark there. You can then say that MAC address is comprised of about 48 bits to 64 bits of hexadecimal digits. Get another mark. Then you can say first half for the manufacturer, second half for the serial number, another mark there. So quite simple. And you do not need to know the types of MAC addresses. So types of MAC addresses you do not need to know for the IGCSE O levels. So we move on to that. We move on to web addresses. So web addresses simply all the characters in our keyboards, they are assigned to something, and we say this is called a CG code. Okay, so therefore, like the letter A on our keyboard has something in relation to a CG code. Okay, for example, right here it's saying A is in decimals 33, hexadecimal 21. Sorry, yeah. So all of that. Okay, so you don't need to understand what these numbers mean, but you simply need to know a CG code is basically assigned to a certain um, hexadecimal value, or it uses hexadecimal values to you know, sorry about that, but we are back. So what I was talking about is web address. Simply a CG code is assigned to you know, the keyboard or the letters, and this uses hexadecimal values in simple terms. Okay, that's all you need to know. Okay, and that's all for that. And then of course we have a look at assembly code and machine code. So assembly code is and machine code, we'll have a look at that later in detail. So basically this is you know, code that the computer understands. Okay, and this uses hexadecimal, and that's why we learned about binary and hexadecimals, because it's part of the language of a computer, and therefore we learn it. Okay, so those are the uses of hexadecimals. So we started with MAC addresses, we had HTML, and HTML we have RGB, we have memory dumps, we have the web addresses, which uses the CG code, we have the assembly code and the machine code. Okay, so I think that was all that we need to know. Okay, was that all? Yeah, that was all. Okay, so those are the uses of hexadecimal. You need to know them so you can revise them quickly. We move on to chapter 2, communication and internet technologies. Again, I made a video on most of these topics already, but again, you know, you can have a look at that. So we're gonna have a look at communication and internet technology. So basically what you learn in this chapter is the different types of transmission rates. We'll have a look at you know, we'll have a look at the error checking methods. Okay, we need to know those. We'll have a look at the web browsers and the ISPs, and then finally we'll end with HTTP and HTML. So let's start with this. Now, using computers have been a vital role in all our lives, okay, because we use computers in day-to-day basis and we send data from one place to another. Now, computer science will help you by saying that, you know, this data is not always safe, and it's very important to ensure that this data is not being changed while you send it to someone. Okay, and therefore we come to this chapter where we're going to have a look at how something is transmitted, how we can check if there's an error, and then of course have a look at, you know, safety stuff, you know, browsers do and ISPs do, and then finally have a look at how to tell if something is secure, how to tell if something is not secure. Okay, using HTTP and then HTML. So let's start with data transmission, and in data transmission we're going to be having a look at three factors. The first one is the direction of data transmission. We're going to have a look at the method of transmission, and finally we're going to have a look at the method of synchronization between the two devices when you're sending data online. So we're going to start with the direction of data transmission. Now, data can be sent in many directions. So we have three directions that we're going to be needing in the computer science syllabus. The first one is simplex, the second one is half duplex, the third one is full duplex data transmission. Simplex data transmission is only in one direction, which is from the sender to receiver, and an example would be from a computer to a printer. The second one is the half duplex data transmission, which can be sent to both the devices or both directions, but not at the same time. And you probably guessed full duplex data transmission is both directions simultaneously. Again, an example for half duplex transmission would be, for example, a walkie-talkie. Okay, because a walkie-talkie you cannot talk at the same time. Okay, that's why they say over and out. Okay, so that is a signal to say, okay, now you may speak. Okay, so that is half duplex data transmission. Full duplex data transmission is like a call right now in the smartphones. Okay, where that simply means that it's both directions simultaneously and it can be sent from A to B or B to A. An example would be smartphones that we have these days. Okay, then we move on and have a look at the different data transmission. So that's quite simple. We had a look at direction. Let's have a look at distance. When having a look at the distance of data transmission, we have two types. We have a serial data transmission and we have a parallel data transmission. The first one, serial data transmission. Serial data transmission is simply when data is sent one bit at a time over a single wire. Okay, as simple as that. So I'm going to highlight this. It's a very good definition. When data is sent one bit at a time over a single wire or channel. Okay, as simple as that. When they ask you what is serial data transmission, state that, you get it correct. Okay, as simple as that. And this method of data transmission works well over long distances because, again, it's one bit at a time. So the likelihood of it being unsynchronized when it arrives is very low. And therefore, usually it works very well over long distances. But at the same time, because it's only one bit at a time, it's much slower than the parallel data transmission. When having a look at parallel data transmission, this is when several bits of data are sent down several wires or channels at the same time. Okay, several bits of data are sent down several wires or channels at the same time. Okay, and this one would be a much faster data transmission rate, but it can have a possibility that it becomes unsynchronized when it is sent. Okay, so there we go, we're done with that. And let's have a look at asynchronous and synchronous. So now we're having a look at the type of synchronization. Okay, so we've had a look at direction. Okay, we've had a look at direction. We've had a look at the type. We've had a look at the direction. We've had a look at the type of data transmission, and we finally are going to now have a look at the type of synchronization. So now having a look at the type of synchronization, we have asynchronous and we have synchronous. Okay, two types of data transmission rates. So we start with asynchronous. Asynchronous data transmission simply basically means is that when data is being sent in an agreed bit pattern. Okay, so asynchronous data transmission is when it is sent in an agreed bit pattern. So this basically means that the data bits are grouped together and then are sent with control bits. Okay, they're grouped together and then sent with control bits. Okay, and that is asynchronous data transmission with the A, asynchronous. Okay, so agreed bit pattern, sent grouped together and sent with control bits. Okay, and we do this so that when it arrives at its destination, it is not in separate groups, but instead all as one. Okay, then we have the synchronous data transmission. Synchronous data transmission is a continuous stream of data. This data is accompanied with timing signals and an internal clock, which basically means that it ensures the sender and the receiver are synchronized with each other at all times. Okay, so that's what synchronous data transmission does. We now move on to the universal serial bus. Okay, and we're learning about the universal serial bus because it is all related to the data transmissions that we just talked about. The universal serial bus is asynchronous data transmission. Asynchronous, remember, is when it is sent in an agreed bit pattern and is accompanied or is grouped together and is sent with control bits. This is USB, universal serial bus. Now, very, very low chances of you asking what the USB is made of. Very, very low chances, but it's good to know. It's basically made of 4 wires. 2 wires for power and the earth, and if you do physics you would know this, and 2 wires for the data transmission. Okay, you know what power and earth is. It's simply types of wires that are used in sort of components. But what's the important part is the advantages and disadvantages here. So here is the advantages and disadvantages table. This is what you really need to know. So devices plugged into the computer are automatically detected is the first advantage. The second advantage is that it can only fit one way, which prevents incorrect connections. And it has become an industry standard, which means that every laptop will have a USB sort of slot, and it should be accepted. And then several different data transmission rates are supported. So according to what device you have, it will support that different type of data transmission rate it supports. And then finally, it is usually ease. Okay, but with the disadvantages, we have a maximum cable length of 5 meters. It has a present transmission rate which is limited to less than 500 megabits per second. So it has a slow transmission rate sometimes, and the older USB standards may not be supported in the near future. Like nowadays, hardly do you ever see Ethernet cables in laptops because everything, of course, is becoming wireless now. That's not related, but in the future, there can be a possibility where we might not even have USB slots. Okay, so where there can be a possibility where we're using no USB slots. Now let's have a look at the error checking methods. Finally, error checking methods. So error checking methods is simply a way to find if data has been corrupted as we sent it. Simple words. Okay, and simply we have a few types of error checking methods that we're going to have a look at. The first one is called parity checking. Parity checking is one method to use to check the whether if it's been changed, not whether the data has been changed. It's a very easy, very easy way to check. Now, with parity checking, each bit is allocated a parity bit. Now, before the transmission takes place, basically what happens is that the sender and the receiver agree which parity bit they will decide. So, for example, the systems, maybe they decide they will use even parity. That means that in the start, they're going to count how many even parties, so how many even numbers of 1, and then in the end they will also count how many even number of ones they are. Okay, so that's how they look at it. For example, you have 11011, okay, and it tells you which parity bit are they using. So what you simply do is add the ones. 1 plus 1 plus 1 plus 1 is 4. 4 is an even number, therefore it will be an even parity bit. Okay, very simple, and it's usually asked in exams. Sometimes they even give you a blank and say fill in this blank to make it either even party or odd party. Very easy questions. These are free marks. You have to simply just count the number of ones. Okay, and if it's you want only 4 ones, then put a 0, or for example, whatever you want to do. For this example, it says that you want to have even party. That means the number of ones should be even. So 1 1 1 plus 1 plus 1 plus 1 is 4. Yeah, there are 4 ones, which is even, so you just add a 0. But if you want odd parity in this, you have to add a 1 so that you can make it to 5 ones, which is an odd number. Very simple. Parity bit is one of the most simple. Sometimes they're also given these tables where you have to find the sort of missing parity bit and then correct it. Very simple, very easy. And then what you have to say is, like, for example, byte 8 has incorrect parity, bit 5 has incorrect parity, you get your 3 marks. Okay, very simple, very easy. So this is all about parity bit. We move on to the next error checking method, and the next error checking method is called automatic repeat request, the ARQ. The ARQ simply basically means it's another method to check whether the data has been correctly transmitted. So what it uses acknowledgements and timeouts. That means that when I send a message, it will use an acknowledgement, which means that the data has been sent and has been received correctly. Okay, and the timeout is basically the time allowed for the acknowledgement to be received. Okay, that means that when I send data, the timeout, for example, I put it 5 minutes. If I don't get that acknowledgement, then it will be sent again. Okay, so that's how it works. Very easy. ARQ. The next one is checksum. Checksum basically is another way to check if the data has been changed or corrupted. Okay, and checksum basically has a look and is sent in blocks of data, and it uses an algorithm. Okay, and this is the algorithm. Divide the sum x of the bytes by 256. So the first one, for example, I have x, I divide by 256. Then I round the number to the nearest whole number. So the nearest whole number, I would make that y. So the nearest whole number, if it's decimals, then nearest whole number down. Okay, so if it's 5.6, you do round down, which will become 5. Okay, not 7, not 6, they become 5. Then you do 5 times 256, and then you do the difference between the initial minus this, and that will be your checksum value. But if it's less than 256, then it will just remain 256. Okay. So here it's saying that if it's greater than 255, that's the only time when you can do it. Okay, that's the only time when this formula applies. Then we have echo check. Echo check simply is when data is sent to another device, and this data is sent back again to the sender. Okay, this basically means that the sender will compare the two sets of data and will then check if there's any errors that are occurred during the transmission process. So it's basically, confirming, okay, is the data that I sent in the start same as I got? But these ones are very unreliable because you cannot identify what error came, so you can't correct the error, because if it's two different data, you don't know where the error occurred. Was it during the sending part, or during finding it, or was the error made when checking? So we cannot tell where this is. But echo check is simply, as in it's called echo check, check if whatever I was sent is the same thing as what I got. Finally, let's have a look at internet technologies. Okay, and here we have a look at ISP, IP address. We have a look at IP addresses and MAC addresses again. We have a look at HTML, and yeah, we then have to look at HTTP and then web browsers. Okay, so let's have a look at this now. So let's begin. So we start with the IP address. Okay, so when having a look at the IP address, ISP. ISP is Internet Service Provider. From its name, as you guys can see, ISP is simply when companies provide the user with access to the internet. Okay, and therefore a monthly fee is usually charged to this, and basically these are companies that give you access to Wi-Fi or to the internet. Okay, then we have the IP address. The IP address is a unique address as the internet protocol address. It's made up of 32-bit numbers, and a home computer is given an IP address, or the phone computer IP address, and it is assigned by the ISP, which is Internet Service Provider, and is unique for each internet session. Then we need to know the difference between the IP address and the MAC address. Now, if you recall what MAC address is, media access control, unique number that identifies the device to the internet. What's the difference? Now, an IP address gives the location of a device, but the MAC address just identifies the device connected to the internet. So that's different. IP address is the actual location of the device. MAC address is just to identify. When having a look at HTML, we've already had a look at this. But in HTML, we have two main things that we need to have a look at. First one is structure and presentation. Now, HTML is not programming language, but instead is simply a markup language, or is simply something that's used for presentation of a text on a web page. So let's have a look at structure and presentation. Structure is the essential part of an HTML document. Okay, it has the meanings of stuff. It has the structure of the document. The presentation is the style of document, like the font or something like that, the style sheet. Okay, that is the presentation. Okay, so we have two types, the presentation and the structure. Then we have a look at the HTTP. Hypertext Transfer Protocol. HTTP is basically some rules that must be obeyed when transferring files across the internet. We'll have a look at some encryptions later on how encryption is done during each website. So we'll have a look at that. We'll also have a look at certificates per website and all of that. But what is important here is that websites with HTTPS is secure. For example, YouTube, you'll see HTTPS in the URL. That means that it is safe. Finally, the last one is web browsers. A web browser is simply a software which allows a user to display a web page on their computer screen. It translates HTML code from websites and shows the results. They have a home page, ability to store the favorite users' web pages, uses cookies. We'll have a look at what cookies are. And usually it's comprised with this. HTTP is the protocol used. This right here is the web service name, and this is the file name. So you need to understand that. Okay, so now we're going to have a break because we have finished 2 chapters. And then later on, we're going to now have a look at the remaining 6 chapters and every 2 chapters we'll have a break. So I'll see you in about 10 minutes, and yeah, so we'll see you in 10 minutes and have a look at logic gates and logic circuits. Okay, so we just came a bit early and we are back. Okay, so finally we're gonna have a look at logic gates now. So we're gonna have a look at some logic gates and talk about logic gates. So we're gonna have a look at logic gates and of course logic circuits. Now here are the 6 logic gates that you need to know that will be asked in IGCSE. The first one is the NOT gate. The NOT gate is a triangle with the circle. The AND gate, the NAND gate, the OR gate, the NOR gate, and the XOR gate. Okay, these are the 6 gates that you need to know. Okay, now truth tables is simply usually what you're given is, for example, you're given a circuit and you're told to find the output. Okay, that's what we're going to be learning in today's video. But before having a look at that, we're going to have a look at the functions of the logic gates, of course. So we start with the NOT gate. The NOT gate looks like this, and basically it has only 2 inputs. Okay, so it has only 2 inputs. Either it can be 0 or it can be 1. Sorry, it only has 1 input. Sorry, it only has 1 input. It can be the 0 or 1. And what this does is basically it's the opposite. Okay, it's the opposite. In the Boolean algebra, we say A and then a line on top. Okay, line on top is A. Then when you want to say the logic notation, we say not A. Okay, not A. Then we have the AND gate. The AND gate looks like this, and you have to simply, so what you have to do for the AND gate is you have to multiply. Okay, so 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, and then 1 times 1 is 1. For the NAND gate, it will be the opposite. The OR gate, it will be addition, so 0 plus 0 is 0, 0 plus 1 is 1, so forth. The NOR gate will be the opposite. So example, I've talked about the NAND gate, it's the opposite of AND gate. NOR gate, opposite of OR gate. And then finally, the XOR gate simply says that whenever you have the same terms, like 1 and 1, then it will be 0. But when you have different terms, then it will be 1 output. Okay, so that's simply what you have to do. Okay, and what you simply do is usually, whenever you're given a logic circuit, you have to label each part with a certain number. For example, you have maybe label this P, yeah, you have to label this Q, label this R, and then label this S. Okay, then what you simply do is this example right here is an AND gate. Okay, you know this is an AND gate, and I can show you right here. This is an AND gate. If I go back to the AND gate, right here, this is an AND gate. Okay, this is an AND gate. So let's identify all the gates here. This is the AND gate. This right here is the NOR gate. Okay, remember the NOT gate is the triangle. The NOR gate is, you know, a bit of a turn there like that. Okay, and then every time there's a circle, it means the opposite of the actual one. This one is the OR gate. This one is the XOR gate because that has 2 lines. After you get to know that, you simply have to split the table. Okay, for example, right here, the input values. You split the table and using the input values. Okay, because you know, for example, in this one, the value of A and B is entering into the AND gate. Okay, and you can see A and B. So AND gate, remember you have to multiply. So 0 times 0 is 0, 0 times 0 is 0, 0 times 1 is 0, all so forth, except 1 times 1 is 1, 1. Okay, and that's how you get the answer. Now, logic circuits, logic gates, you know, it's quite hard to explain it like this, but instead you should best do it with practice. So I advise you to, you know, do some questions and then look at the marking scheme if you're correct. But simply what I just said was the basic of logic gates. Circuits, I cannot, you know, explain more about this. This is more of a thing that you have to do more practical and not, you know, theory. So practice on the gates and you should be okay. And you can already see, you know, it's a small chapter related to these circuits. So these are just some examples. Do these examples. I won't be doing them right here because it's quite hard to, you know, draw them, but, you know, hopefully you understand this. So we're going to skip over to chapter 4 where we talk about the operating systems and the computer systems. Okay, so operating systems and the computer systems. So let's have a look at this now. Okay, so we're having a look at operating systems and computer architecture. Okay, we're having a look at all of this. Okay, now operating system is simply a software that runs in the background whenever you're using a computer system. Okay, so whenever you're using a computer system, we need operating systems. Okay, so in this case, what you need to know first of all is some uses of the operating system. Okay, so for example, one, error handling, two, batch processing. I'm just you can pick any from these. Okay, any from these would be correct. Anything from here would be correct. Okay, as you guys can see, anything from here would be correct. Okay, so hopefully that you have understood, and hopefully you have got that. Okay, so those are just some uses that you need to know. This one I cannot explain this. You just need to know the uses of the operating system, and I can't do that, but instead you have to learn it yourself. Okay, I cannot help you in memorizing the following. Okay, so hopefully you have understood that, and you've got or understood that. Okay, we move on now. Okay, we move on, and now let's have a look at interrupts and a buffer. Okay, so operating system, remember, is basically a software that runs in the background whenever you're using the computer. So let's have a look at what an interrupt is. An interrupt is a signal, sent from a device or from the software to the processor. An interrupt is a signal that is sent from a device, sorry, very sorry about that, but we move on, we continue. So interrupts and buffers. So interrupts, what I was saying is it was a signal that is sent from the device to the processor. Now you'd ask yourself, why do we need an interrupt? What's the signal about? Now the signal is simply a sign to tell that you need to stop whatever you're doing. It tells the processor, stop whatever you're doing and help me, in simple terms. Okay, so an example would be, for example, you're printing something and the printer says that it has a paper jam. An interrupt will come up, a signal will come up, and then it will send to the processor. Okay, and then once when the interrupt signal is received, the processor can either carry on with what it does or it will stop and service the program. That's simply what an interrupt does. It's a signal sent to the software or to the processor, or from the software to the processor, to stop whatever it's doing and focus on what it needs help on. Then we have buffers, which are used in computers as a temporary memory area. Okay, so basically the buffers are used in the computers as a temporary memory area. Okay, this basically means that these hardware devices operate at much slower speeds. Okay, what that basically means that, for example, I'm streaming right now. Buffers basically help the computer that you're watching this device on to know ahead of time. Okay, to know ahead of time. So therefore, there won't be any buffers, as its name comes. No buffers. There won't be any stops, and therefore, there'll be a smooth run of entire or everything. Okay, so that's why we use buffers. So that's why we need buffers. Okay, and that is the importance of a buffer. Okay, so we move on now, and we have a look at. Okay, these are just some examples that are given by the notes. Some examples of when you would need a buffer, but a good example would be when you have the video. That is the best example that I can give you. Okay, so let's move on now. Let's have a look at computer architecture. Okay, so that was just about computer systems. It's quite a small topic about computer systems, but now we have computer architecture. It's a big topic, computer architecture. Okay, computer architecture. What is computer architecture? Now, computer architecture, from its name, is simply what a computer is made up of. Okay, what is it made up of? Okay, in simple terms. Now, a computer system, or the stored program computer, we say something called the von Neumann architecture. Okay, so a common term that's usually referred is called the von Neumann architecture, and this is a concept that was invented by John von Neumann. And this basically was an idea of the stored program computer. Okay, and his idea was that, to hold programs and data in memory. Okay, so you basically hold the programs for future use, and we use something called the von Neumann architecture for this. Now, the von Neumann architecture has a diagram. Here is the diagram that we're going to have a look at. So here is the diagram. Hopefully you can see it. So the diagram basically starts with the processor, which includes the control unit. Okay, so we have the processor, which includes the control unit. We have the memory unit, input and output, and then we have the LO device and the LO device. Now we have three types of buses that you will come across. We have the address bus, the data bus, and the control bus. Okay, these three types of buses. Okay, so here's a table that is explaining each three type of bus. Okay, yeah, so we have the address bus, data bus, and control bus. Okay, so the address bus will carry signals relating to addresses. Okay, so it carries signals related to addresses. Okay, and it's unidirectional. The data bus sends data between the processor and the memory unit and the input and output devices. So it sends data between the processor, the memory unit, and the input-output devices, and is bidirectional. The control bus will carry signals relating to the control and coordination of all these activities within the computer, which is unidirectional. So control bus deals with all the signals relating to control and coordination of all activities. Data bus sends data between the processor. Address bus carries signals relating to addresses. Those are the functions of each. Here we have a diagram again of another sort of thing that you need to know. Okay, so yeah, that is that. And now let's have a look at how everything works. Okay, how does this work? Now, an address is the location of where the data can be found. Okay, and you need to know how everything works, and I think you will learn it in the fetch execute cycle in just a moment. So we have the memory unit. In the memory unit, it's basically the number of partitions, and each partition consists of an address and its contents. This is very rarely asked, but you need to know this. The MAR is the memory address register. The MDR is the memory data register. ALU is arithmetic and logic unit. PC is the program counter. And CIR is the current instruction register. Okay. So here we just have some examples of how they're looked at. And then here we are told what a processor is, what a control unit is, and what input and output devices are. So a processor basically contains the arithmetic and logic unit. Okay. And the ALU allows arithmetic and logic operations. Basically, this is calculations. The control unit operates the memory, okay, processes the input and output devices, and it also contains the CIR and the PC. We'll have a look at what each function does in the fetch execute cycle that we're going to have a look at. Input and output devices, we have been seeing this since everywhere. Input and output devices, very common in these exams. We have so many input and output devices: printers, monitors, loudspeakers. We all know what this basically means, so shouldn't be a problem. Okay, so what is the fetch execute cycle? The fetch execute cycle is basically used to carry out some instructions. The processor, first of all, fetches data and instruction, and then from the memory, and stores them in a suitable register. Okay, so here is how the fetch execute cycle works. In the fetch execute cycle, the next instruction is fetched from the memory address currently stored in the PC. So instructions are then fetched from the PC. They are then stored in the CIR, and the PC is then incremented or increased by 1 so that the next instruction can be processed. Execute simply basically means that the processor passes the decoded instruction as a set of control signals. Now I have made a video on this, but this is the main table that you need to know. Okay, this table right here that I'm going to show you here is what you need to understand. The first one, the program counter, the PC, contains the address of the memory location for the next instruction to be fetched. The address is then copied from the PC to the memory address, the MAR, and is done by the address bus. So the PC to the memory address register. So the PC, remember, contains the address of the memory location of the next instruction, which has to be fetched. Okay, then the PC, the address is then copied from the PC to the MAR with the address bus. From the MAR, it is copied temporarily to the MDR. Okay, and then from the MDR, it is converted to the CIR. Okay, and then finally, again, if you want to see which buses do the following sort of stuff, let's have a look at this. Okay, so the first one, remember I told you it was this one is done by the address bus. This one is done by the one second, this one is done by the data bus. The second one is done by the data bus. So let me go there back. So the second one, so let me do it right here. So this one is address bus. So we have 3 address bus. Then we have the one second, we have the data bus. So I'll just write that up, data bus. So we have the data bus, and then we have the control bus for here, and here we have the address bus. Okay, these are the buses that are used to convert the stuff. So the first one is the address bus, the second one is the data bus, third one is the control bus. Okay, those are the ones that you need to understand, or you need to know. Okay, so hopefully you have got to know what this basically does, what it basically means. You can have a read on this. You can pause the video and see what is happening, what everything that's happening, and what is being done. Okay, so that is that. Hopefully you have understood this, and the next chapter we're going to have a look at is input and output devices. Okay, and that will be the next one. You can see how many input and output devices are, so we're going to quickly go over all of them. So let's move over and do that. So again, we'll take a 10-minute break like the other one. Okay, so finally now let's have a look at the input and output devices. So yeah, we're going to be having a look at input output devices. Now this is one of the longest chapters. As you can see, all the input and output devices, it's so long. So let's see how long this is going to take. This is chapter 5, so we have 3 more chapters after this. So let's have a see. Let's have a look at this now. So I think the next chapter. What's the next chapter? Let's have a look at the next chapter. The next chapter is on. You see how long it is? Very long. The next chapter would be. Ooh, so long. Still continuing. Still continuing. Still continuing. Wow. Still continuing. So it's still continuing. Wow. 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 This one is taking us a long time. Then the next one is about data storage. Yeah, so data storage, and then we will conclude, or no, then it's chapter 7, I believe. Then we're going to have a look at high and low level languages, and then the next one is errors, and then we're not going to be doing practicals, remember, because we're only going to do theory. Okay, so let's start input and output devices. Long topic, big topic, very about 60 pages. Okay, input output devices, let's begin. Let's see what we can do. So now input devices that you need to know, and these are the output devices. So here's the input devices you need to know, these are the output devices you need to know. So let's have a look at each of them. Of course, we're going to be looking at each of them step by step, like what scanners are, interactive whiteboards, all of that, so on and so forth. Now scanner, we have scanners, barcode readers, quick response, digital cameras, keyboards, pointing devices, microphones, touch screen, sensors, interactive whiteboards. Then we have inkjet printers, laser printers, 3D printers, 2D, 3D cutters, actuators, loudspeakers, LCD, LED, and then projectors. So we're going to have a look at all of these individually and how they work. So that's why it's that long. And then again, we're going to have a look at some further, inside stuff like LED, how they work, difference between LCD, LED, and so on and so forth. Let's start with the input devices. Let's start with scanners. Now, a scanner is a 2D or a 3D, two-dimensional or 3D. Hopefully, you know what that means. Now, two-dimensional scanners, sorry, are basically these are types of scanners that are usually used, or the common ones that are used. And what this one is basically this is the one where it's simply the image is converted into an electronic form and can be stored in a computer. So this one is stored onto the computer as it is converted to the electronic form. Okay, so this is how you use the scanner, and nowadays everyone knows how to use the scanner actually. So what happens is basically a bright light illuminates the document and it's converted into electronic form, and then it can be stored onto the computer. That's how a scanner works. A three-dimensional scanner is a bit different because this one scans solid objects because of course it's 3D. And what it does is that it takes different images of the points, and then it comes up with one 3D dimensional scan. And usually for projects when we're having a look at buildings, we use 3D scanners. So what are some applications of scanners? So the first one would be 2D scanners are used at airports to read passports, and they can also be used for OCR technology, which is basically digital images which represent the passport pages, because the OCR technology is of course used. Okay, so basically, we don't need to know a lot about this, but basically, whenever in the airport we go in the airport, they usually ask you for, some form of, um, Face ID, for example. So we use the scanners for this. We use scanners to identify following. Okay, so for example, right here it's saying you can do the distance between the eyes, width, and the nose, the shape, the cheekbones, everything. It's done by scanners, 3D scanners to be more specific. Sorry, 2D scanners. But 3D scanners can be used again for X-rays, for buildings, as I was telling you before, so that you can see how it will look in real life. And yeah, so scanners are really important. But usually in O levels, I believe they don't even ask you that much detail, but instead you only need to know the fact that scanners simply converts some object to an electronic form which can be stored onto the computer. That's what you need to know, like, mainly. Then we have a look at barcode readers or barcode scanners, and basically what this basically means is that a barcode uses or reads. Okay, so this is a very interesting input device. So what happens is that barcodes, they're comprised with different lines, parallel lines, with different thickness. So what the barcode does is that when you scan it, what it'll do is it'll see, depending on the width, the intensity, meaning if it's darker, lighter, it will scan that, and then it will come up with the information that it needs, and it's usually used for shopping markets or something like that. So this is an example of a barcode, as you guys can see right here. And when you put the barcode on top of it, it will measure the thickness of the lines, the white parts, the dark parts, thin parts, and everything. And that's how it comes up with stuff. Now you don't need to know all of this. Never asked, rarely asked, so you never need to know that. You don't need to know that. Now, barcode is first read by LED, then the light is reflected back off the barcode, and then the reflected light is read by the sensors. Then after that, the LED light is scanned across the barcode and is converted to digital data. Okay, or electronic form, but it's simply converted into a certain data type of data. Okay, so that's how it works. Okay, and it's a quite simple way on how it works. And yeah, quite simple way. Now let's move on and let's further talk about this. Okay, so now let's further develop this. Now what it basically says that input and output device and how it's used. So here we have some examples of each of them, or some examples of some input devices. And what we have to do is tell you how it is used. Okay, so the first one, keypad. Okay, keypad is basically to key in the number of the same items bought. Then we have the monitor, which is used to see the cost. We have the speaker, which can make a beeping sound every time the barcode has been read. We have the printer, which will print the receipt. We have the magnetic strip reader, and then we have the touchscreen. So whenever you go to like a shop, whatever you see is probably what you need to know or get to know. Okay, so it's quite simple and quite very easy to understand, I would say. So there shouldn't be any difficulty in this. So let's move on. Let's talk more about barcode readers. Okay, so the barcode has been read. What happens then? So what you can say, sometimes they can ask you, how does the whole procedure of stock work? So basically what you can say is that you can have the database, the stock database, having a key field for each stock. So when the barcode number is found, the stock item will be looked up, then to reduce once when it is paid for. It will be reduced by 1. Then the new value of the number stock is written back to the stock item record. So this is more of general knowledge, so it shouldn't be a problem actually. It's more of general knowledge for this part of the question. So that is that. We can have a look at advantages. So in advantages, it's easier, faster. No need to price every stock item. You can automatically detect. Allows automatic stock control, and with the advantages of using a barcodes to the customer would be that faster checkout, so you don't have to waste time. Also cost savings can be passed on the customer. There will be fewer errors. So that's that. Let's have a look at QR codes, quick response, and this is another type of barcode, and it's made up of matrix. The other one was made up of parallel lines. This one is made up of matrix filled in dark squares. Works the same as the barcode reader. That's why it doesn't show a lot about this, but it's basically made up of matrix squares. Then we have the digital cameras. So a digital camera is simply used as a traditional camera to, record photos. The film required developing and then printing before the photographer can use. Now, in the olden times, there was nothing like this. They had to do it the old primitive way, the hard way, and now, technology has improved by a lot, so everything is becoming really easy. So digital cameras being one of them, where it basically records photos and videos. And cameras can now be controlled by microprocessors. It can adjust shutter speed, focus on image automatically, adjust aperture size, adjust size of the image, and there's a lot that it can do. Then we come over to keyboards. I'm skipping some stuff because it's usually not relevant in the IGCSE exams, never asked, so that's why I'm just skipping through it, because right now we are focusing on only things that will come on the IGCSE exam. But again, at your free time, if you want to read this again, the notes are down in the description, so you can have a look at that. So keyboards, let's have a look at what a keyboard is. Keyboard is the most common input device that is used for data entry, and basically input device on computers, tablets, mobile phones, and other electronic items. And of course, there is also the keyboard that is classified touchscreen technology. So we also count that as a keyboard. Okay, the ones that are on your mobile phones is still a keyboard. Okay, and we have something called the ergonomic keyboards, which basically are for people that have RSI in the hands. So if you use RSI, is basically repetitive strain injury. What it basically means that when you use the computer a lot, sometimes you can have some errors, or not errors, sorry, you can have some problems that can occur, and therefore we have a special keyboard made for that. It's called the ergonomic keyboard, or sometimes they say for disabled people. Okay, and yeah, so that is that. Hopefully you understand keyboard. When having a look at pointing devices, we have a mouse which uses a tracker ball. Okay, it uses that tracker ball right here. Okay, so for example, like right now in this live stream, I'm also using a mouse like this. This is a mouse, if you can see right here. And if you notice behind the mouse, this right here is basically infrared sensor. So wherever I'm moving it on my table, it will detect the movement, and accordingly it will move my cursor or mouse. So that's how a mouse works. So it detects, the infrared will detect what happens, and then will monitor the sort of movements I'm making with my hand or with the thing. And then of course it has the tracker ball, which you can see right here. It has the tracker ball too, and then the left click, right click. Okay, simple mouse, but hope it gets the job done. Let's have a look at microphones. Microphone is an input device, okay, and it's used for voiceovers. Right now I'm using a microphone, voiceovers to talk over the stream, and so on, so forth. And microphones are usually now built into laptops, computers, phones. All electronic devices usually have a microphone, so it's become more of a standard use, and most devices have microphones. But in the old times, you had to separately buy the microphone and then connect it to your external device. The way nowadays, you have a monitor and you separately attach it to the PC. But of course now technology has improved a lot. Here we have some irrelevant stuff about some speech recognition and so on and so forth, stuff like that. When having a look now, finally, let's have a look at touchscreens. Okay, so we have, I believe, three types. Okay, we have the capacitive, we have the infrared, and we have the resistive. Okay, we have those three: capacitive, infrared, and resistive. So let's have a look at the first one, capacitive touchscreen. So a capacitive touchscreen is made up of many layers, and so here's the keyword: many layers. It's made up of many layers of glass that acts like a capacitor that creates electric fields between the glass plates and the layers. So it's many layers that creates electric field which detects movement on your hand. When the top glass layer is touched, the electric current changes, and this will therefore locate the coordinates of where the screen was touched. Okay, so the electric current will change, and that's how it's identified. The benefits of this is that it's a medium cost technology. The screen visibility is quite good in strong sunlight, of course. It permits multi-touch capability because, again, when it detects two change in currents, it can be a bit, good and quite good or capable of doing that. The screen is very durable and will take a major impact to break the glass. The drawbacks is that it allows only the use of bare fingers and not the use of gloves, for example, if you're using gloves, because with use of gloves, it will not detect that electric current. Okay. Infrared is heat sensitive, and they're optical. They're two types. Heat sensitive uses glasses. Optical also uses glasses. Both of them are the same, but with the difference is heat sensitive needs a warm object like fingers, but optical it uses anything. Okay, it can be whatever is touched on the screen, it will be using a grid coordinates system to locate where or what part of the screen is touched. The benefits of this is that both systems allow multi-touch capabilities. Basically, I can click two things at the same time and it will detect. Also, the optical system will allow the use of bare fingers, gloved fingers, or a stylus. So you can use a stylus. You can also use gloves, and they have good screen durability. So you can see durability is in all three, I think, except the last one. The drawbacks is that it's relatively expensive. Heat sensitive system only allows bare fingers because again, you need something warm, and both systems have fairly good screen visibility in strong sunlight. Okay, which I don't know why isn't a drawback. So I think it's the problem with the notes because yeah. Okay, resistive, the last one. This makes use of an upper layer of polyester, so it's a type of plastic, and it's basically again layers. So if you've noticed, most of them are layers. Even the previous one was a layer. Yeah, so most of them are usually layers, and this one is made up of polyester. And the top polyester, bottom polyester is basically completes the circuit. The benefits, let's move on there. It is relatively inexpensive. And so the only thing that's expensive is the infrared, I believe. Yeah, that's the only one that's expensive. The other one's resistive is not expensive. You can use bare hands, gloves, and the drawbacks is that screen visibility is poor and it does not permit multi-touch capability. Let's move on to sensors. So with sensors, it's a very important, but let's have a look at each sensor individually. So we start with temperature. Temperature can be used to control heating systems, monitor chemical process, monitor temperature. Anything related to temperature is used a temperature sensor. The next one is moisture. Okay, so we have temperature that we did. So control heating system, chemical process, greenhouse. Okay, so this is everything related to temperature. When having a look at moisture, you can have to control and monitor the moisture levels of the soil. Okay, moisture levels, humidity levels, dampness. So usually it relates to something in the greenhouse or the factory. Then we have light, switching on the light on and off, monitoring car control levels, automatically switch on the car's headlights when it gets dark. Then we have infrared. So for you understand that. Okay, infrared is, for example, turn on wind screen wipers, automatically detect intruders, burglar alarm, count people entering, leaving building, pressure, anything related to pressures. Then we have sound, we have gas, we have pH. So you can see how many we have. We have many. So you can you need to know these ones. Okay, so let's move on. So here is just some more examples related to that. So yeah. So here, what these questions are is simply the use of a microprocessor. Okay, and this was a new segment that's usually asked, and I think I predict that next year this question will come. According to my predictions, this question may come. So this one is more of knowing your computer science in whole. You can't just teach it. You need to know how a microprocessor works and the sensors that it needs. And this one I can't really explain right now, but hopefully maybe a future video I can have a look at many examples and teach you how to sort of do it. Okay, so let's move on to output devices. So an output device, we start with inkjet printers. Now an inkjet printers is usually made up of spray droplets. So it sprays droplets and then prints something. It has an ink cartridge or cartridges, so it uses ink cartridges or cartridges, which is for each color, blue, yellow, magenta, and of course the black cartridge. So if you see in your printer those four colors, if you have an inkjet printer, nowadays it's usually used in many homes, so you should have a inkjet printer. It has a stepper motor which moves the print head so that it can spray the droplets, and then of course the paper needs to be feed by you, not automatically. So here is some process of how the inkjet printer works. So data is sent to the printer. So this is general knowledge. Data is sent to the printer. Printer ensures the format is okay. Checks if the printer is made and sure. The data is then sent to the printer in temporary memory known as printer buffer. We've talked about printer buffer. A sheet of paper is then fed into the main body. It goes over the body, prints the things by spilling the droplets. Each full pass of the print head advancedly very slightly to allow the next line to be printed. So it moves next line line by line. Then if there's more data in the print buffer, it will repeat the stages, and then finally when the printer buffer is empty, it will release the paper. So that's how an inkjet printer works. Let's have a look at the laser printer. The laser printer says that laser printers differ greatly from inkjet printers, the way they print pages. So they use a dry powdered ink. They use a dried powder ink rather than liquid ink, and they make use of properties of static electricity to produce the text and images. Okay. So yeah, laser printers, this is how they work simply, but this one uses a drum that rotates. So similar to the inkjet, except this one uses drum rotates, and the toner, it uses toner. So yeah. Applications of inkjet and laser. Inkjet is best for one-off photos, while laser is good for high-quality printouts. Then we have 3D printers. 3D printers is simply used to print three-dimensional objects. The other ones were 2D. This one is 3D, and it uses materials, and it's made layer by layer. And yeah, so this is more straightforward. So what it does, it's used with blueprints, or we say CAD software. Then it's sent to the printer. The printer will then you have to choose the material. It will print with the material, and the solid object is built up layer by layer, and then it can take a long time, usually several hours, depending on the thickness of the layers that you use and the material that you use. You can also use 3D printers to cut stuff, not only to print stuff but to cut stuff, because if you replace the part where it prints to a cutting object, it will cut stuff for you. So it'll carve stuff for you. Uses for 3D printers, kind of general knowledge. I believe it's quite general knowledge. Like you have fashion, art, technology, parts in aerospace, because they need to be precise. Anything that needs to be precise will be needing a 3D printer. So actuators will be talked about later, but simply they're used to control applications. Loudspeakers, headphones. You can see how long this topic is. Very, very long. Okay, this topic is a long. So it's a very long topic. So loudspeakers, headphones, they basically data from digital to analog, and as you can see the diagram right here, from DAC to amplifier. We move on to LCD LED. Again, I'm skipping some stuff, but again, you can read that all because some of this is unnecessary. Like you don't need to know the rate at which the DAC translates. Okay, so you don't need it. Okay, so LCD LED. Wow, very long topic. LCD LED, then OLED, and then projectors. Wow, very, very long topic, but we'll do it in this live stream. As you can see, this live stream is very long because we're covering all the topics that can ever be found in computer science. So LCD LED. So here we have the liquid crystal display LCD technology. That's the full form, liquid crystal display, and it's used in televisions these days. So basically it's made up of layers. So yeah, now when having a look at some characteristics of LEDs, They are more popular because of the advantages. One of the advantages is because maximum brightness, whiter light, brighter light. They last almost indefinitely. Okay, because you can see nowadays even some old old televisions, they still have LED that are even like 20 years old, and LEDs consume little power. That's why you would use it over LCDs. LCDs are old. OLED is the new ones. OLEDs are brighter light than LEDs. They don't need backlighting like LCDs, and they're modern. Okay. When having a look at the projectors, basically a projector uh, uses something called the DLP chip, the DLP, sorry, DLP chip, which is the digital light projector. Um, so digital light projectors, DLP chip. Okay, that's why it's called digital light projector. So basically, it uses mirrors too, and then projects on the screen. We know how projectors work. LCD projectors are older technologies than DLP, but it's the same thing. So it sends a powerful beam of white light from the bulb or LED inside the projector body, and then this beam of light is sent to the group of chromatic coated mirrors. Okay, so that's how it works. And finally, now chapter 6. Okay, chapter 6. Here we are going to have a look at memory and data storage. Okay, so let's have a look at memory and data storage. So again, we're going to be having a 10-minute break and then have a look at this. Memory and data storage. What's up guys, welcome back to another computer science video. Today we're going to be looking at the memory and data storages. So today we're going to cover the entire chapter related to memory and data storage. So further ado, let's begin. So in today's video, we're going to be looking at the different file formats such as the MIDI, the MP3, the JPEG. We'll also be looking at the file compression techniques. We're then going to be looking at primary, secondary, and offline storage. And finally, we're going to end with magnetic, optical, and solid state media. So let's have a look at the introduction. So basically, there are many file formats used to store data, and it can be either text, it can be image, it can be sound. So we have different sort of types of formats, okay? And in this chapter or in this video, we will be considering how file compression is used to save memory into your computer. So these computer systems have primary memory, secondary memory, and the main technologies used are the magnetic, optical, and solid state. These are basically storage devices: the magnetic storage device, optical storage device, and the solid state storage devices. Okay, and they all use technologies that is going to be described in today's video. So let's begin. First of all is file formats. Okay, we're going to look at the different file formats. So as you guys can see, there's a list right here. We have the MIDI, we have the MP3, the MP4, the JPEG, and the text and number format. So we're going to start with MIDI. So the full form of MIDI is Musical Instrument Digital Interface. So Musical Instrument Digital Interface, the MIDI. So what is this? So this is basically a storage device for music, okay, specifically for music. It just comes from its name, Musical Instrument Digital Interface. It stores music files. However, the MIDI files are not music and don't contain any sound. So it is usually thought that it stores music, but it's actually not. So that's something cool to know. But the MIDI files are not music and do not contain any sounds. They are very different. For example, the MP3 files. Okay, so the MP3 files can store music or sound, but this is not like that. The MIDI is essentially a communications protocol that allows electronic musical instruments to interact with each other. So it's a communications protocol that allows electronic musical instruments to interact with each other. The MIDI protocol uses an 8-bit serial transmission, and we have learned serial transmission in the previous videos. Basically, serial transmission is in one direction, 1 bit at a time, with one start bit and one stop bit, and therefore it is asynchronous. We have also looked at asynchronous in this, in the videos that I've been posting on computer science. An MIDI file consists of a list of commands that instruct a device, okay, on how to produce a particular sound or music note. Okay, so it's all related to music, and therefore it comes it's not like stores music or anything, but it deals with the sound of music. Okay, so that's essentially what's there. Next up is that the first byte is the status byte. So how does the MIDI work? So the first byte that is sent or is the status byte, and this basically informs the MIDI device what function to perform. Then after that, encoded in the status byte is the MIDI channel, and the MIDI operates on 16 different channels, which are numbered from 0 to 15. Okay, so let's look at some examples of the MIDI. Okay, the MIDI commands would be note on and off. Okay, this indicates that the key has been pressed to release. Like that would be for like an electronic keyboard. You can tell that once when I've pressed, it will be either it's on or off. Okay, then it looks like key pressure. With the key pressure, it indicates how hard the key has been pressed, and this could indicate the loudness of the music note. Then additionally, the bytes are required a pitch byte, and then we have the velocity byte, which tells the device how loud to play the note. So basically, when the music note is played, or when the sound is recorded on a computer system, the MIDI messages are saved in a file which are organized by the file extension, the MID dot. Okay, so this is the file extension, the MIDI. Okay, MID, sorry, dot. So the .mid file is played back through the musical instrument, such as an electronic keyboard. Okay, the music will be played back in an identical way to the original. So basically, the MIDI is simply just how it can play electronic music. Okay, it basically processes and then sends the audio back, and therefore the musical note is sent, and it can store the entire piece of the music, whatever you play. Maybe from a keyboard, it will store everything depending on the pressure, depending on, you know, all the top things mentioned. If you have pressed a note or not, it will record that, and that's where MIDI files are, and then the MIDI files are stored on the .mid. So that's a lot about MIDI, and it's very important apparently in IGCSE. It's a little off topic to computers, but it is MIDI, and simply the MIDI helps or allows electronic music instruments to interact with each other. So in simple terms, an MIDI is something that allows an electronic musical instrument to interact with each other. So now we move on to something that's really popular, the MPEG-3 and the MPEG-4. We usually always encounter this when we are, you know, looking at files, or when we're downloading something. It's always MP4, MP3. We also have the device, the MP3 player. So what is this MP3? What is this MP4? You know, what is it all related to? So let's start with the MP3. Okay, the MP3 uses technology known as the audio compression. Okay, to audio compression to convert the music and other sounds into the MP3 file format. Okay, so essentially this compression technology will reduce the size of a normal music by 90%. So this is where compression also takes part, and also in IGCSE you need to know about compression, and we will talk about that in future videos. So basically compression is taking place, and it reduces all the way to 90%. Okay, for example, an 80 megabyte music CD can be reduced to 8 megabytes. Okay, so it is compressing without anything getting lost. Okay, so the MP3 files are basically used in MP3 players, computers, or mobile phones, and these files can be downloaded from the internet, or CDs can be converted to the MP3 format. But how can the original music file be reduced by 90% while still retaining its music quality? So this is done by the file compression algorithms, which use peripheral music shaping, which is basically essentially that removes sounds that the human ear can't hear properly. Okay, so that's just a brief you know, way on how compression works. Basically, some sounds are not heard by humans. Okay, in physics, if you have done it, you know that humans can't hear below 20 hertz and more than 20,000 hertz. So in the MP3, things that are below 20 hertz, it will compress, and therefore it will make a difference for the human ear, and still keeping its quality and reducing its sort of it's removing its what do you say, the size. Yeah, it removes the size. Okay, so these MP3 files use what is known as a lossy format, since part of the original file is lost, losing the compression algorithm. So basically the MP3 files are what happens is that the lossy format, okay, the MP3 files use what is known as the lossy format. Okay, basically lossy format is reducing the compression, and then what the format it is right now currently in, that becomes the lossy format. So after keeping that in mind, you know, we have now the MP3. So MP3 is basically compressed, and then we have got that. Now we move on to the MP4. The MP4 is a bit different. The MP4 stores video. Okay, not it does not. Okay, it also stores music, It stores a lot actually. The MP4 stores music, videos, photos, animation, but usually it's for videos along with audio. And videos could be streamed from the internet using the MP4 format without losing any real discernible quality. We then finally come to JPEG files. JPEG files are very important with images, or not important but very common in use with images. The resolution of the photograph is reduced from A to E, for example. Okay, from such a resolution, it can go to resolution like this. Okay, and this reducing the pixel resolutions. Okay, the number of pixels are reducing. Okay, and that's how we come to this. Okay, next up we have the sort of formats. You can have a BMP image, you can have a TIF image, you can have a BMP image, so on, so forth. Then we move on to some text and number file formats. Okay, we have the CG format that we looked in chapter 1. You can watch that video. I did talk about a brief CG format and how it uses hexadecimal. Okay, so hexadecimal is used in the CG format. Basically, you can check that video. In the end, I talk about uses of hexadecimal, and in that, a CG format comes into play. So here we just talk about more about the text and number file formats, so on, so forth. But we talked about lossyless and lossy compression, and I was actually not aware that it was going to be in the same chapter. But let's have a look at this: the lossyless and the lossy file compressions. So with the lossy file compressions, basically the data bits from its original data are reconstructed. Okay, when the file is again uncompressed, this is particularly important. So basically, lossy file compression is when it is compressed from the original file. Okay, and then the file is again uncompressed. Okay, we look at this more in detail. Basically, with lossy file compression and lossy file with lossyless and lossy, you just need to know the meanings of it, and that's, I think, most important. Sorry, not most popular, but you just need to understand about that. So with the lossy file compression, you need to know that MP3 and JPEG formats are examples of that. And with the lossyless, it could be like a spreadsheet file. Okay, so there it is. We looked at all the compression. Okay, so yeah, so that was basically a video that I made some time ago. Just played it onto this live stream, and we're going to continue from there, and we're going to have a look at memory and storage from there. So when having a look at memory storage, we have three types. We have the primary memory, the secondary memory, and the offline memory. It's actually a quite big topic where we cover primary, secondary, and offline storage. Okay, so let's start with this. Let's start with primary memory, then move on to secondary memory, and then finally end on with offline. So we start with primary memory. So when having a look at primary memory, we're having a look at RAM and ROM. Okay, RAM, ROM as the primary memories mainly. Okay, so what is RAM? So RAM is the random access memory. Okay, and this one is temporary. Okay, it's a volatile. Okay, this basically means that when the contents of the memory are lost due to power, maybe, you cannot retrieve it because it's temporary. Okay, and it's usually used to store data, files, and parts of the operating systems that are currently in use. Okay, that are currently in use. Now it can be written to or read from, and contents of the memory can be changed. Okay, so that's RAM. And then we have the dynamic RAM. Okay, the DRAM. Okay, and this basically means it's a number of transistors that have tiny single RAM chips that contain millions of transistors and capacitors. So usually in this IGCSE exam, you only need to know RAM and ROM. You don't need to know DRAM. So I'm just going to skip that for now. So when having a look at ROM, okay, ROM is read-only memory. That one was random access memory. This one's read-only memory. This one is non-volatile. That means it's permanent. Okay, so read-only memory is permanent. Random access memory is temporary. Temporary is the same thing as volatile, and permanent is non-volatile. Okay, and it's usually used to store important documents, so that in case power is lost, you can retrieve it. And because it's only read-only memory, it cannot be changed. That one can be changed, I believe. Yeah. So when having a look at the application of the two, the ROM is used to store factory settings, remote control frequencies, startup routines, set routines, and stuff like that. Stuff that are used on a daily basis. RAM though, the ROM, sorry, that was because you don't need to edit anything because it's the same process again and again. But for RAM, you have its own routines, new instructions, and can be used to receive and send instructions. So now let's have a look at secondary storage. In here we have a look at HDD, SSD. We look at those two, SSD and HDD. So let's have a look at those two. So let's start with HDD. HDD is simply the most common method to use to store data on a computer. Okay, so data is stored in a digital format on the magnetic surfaces of the disk. Okay, so data is stored on the magnetic surfaces of the disk, which is called platters. Okay, and the hard disk drive will have a number of platters which spin about 7,000 times a second. So very quickly it spins, and the number of read write heads can access all the surface in the hard disk drive. So basically the data is stored on the magnetic surfaces, and HDD has magnetic surfaces. So sometimes in IGCSE questions they can tell you to differentiate between HDD and SSD, SDD, sorry. So you need to know the full. Okay, so then we have a look at, normally each platter will have two, typically they can move from center of the disk to the edge of the disk and then back again 50 times. Then we have SSD. SSD is solid state drive, and they have no moving parts. HDD has moving parts. This one has no moving parts, does not rely on magnetic properties, and yeah, so on and so forth. You do not need to know EEPROM, so I'm going to skip that. Okay. So what is the main benefits of using SSD rather than HDD? So here's the summary. They are more reliable because it has no moving parts. So SSDs are more reliable. They are lighter, which makes them suitable for laptops. They don't get up to speed until they work properly. So they, once when they work properly, they get up to speed. They have low power consumption, no moving parts, therefore they're thin, and its data can be accessed much quicker than HDD. When having a look at offline storages, we're having a look at CDs, DVDs, Blu-rays, I believe, DVD, RAM, so on and so forth like that. So let's have a look at that right now. So CDs and DVDs. So when having a look at CDs and DVDs, these are basically optical storage devices, and they use laser light to read the data, while Blu-ray uses blue light. You'll see that right now. So it's basically a spiral track. General knowledge, you should know this. So it uses red laser. Okay, that's mainly what you need to know. DVD RAM it uses a different technology to CDs and DVDs. But basically what they do is, instead of a single spiral track, they use concentric tracks. Okay, that's the difference, and this allows them to simultaneously read and write operations to take place. Blu-ray, as I said, Blu-rays use blue laser rather than red laser compared to DVDs. Okay, so that's that. Here is the quick summary between the two. So CDs, red laser, DVDs, red laser, Blu-ray, blue laser. You don't need to know the wavelength, but if they ask you, good. Blu-ray has the smallest wavelength, CDs have the biggest one, and yeah, so that's that. Okay. Flash memories, USB flash memories. Basically, it's a solid state technology, SSDD. So it's lightweight, portable. General knowledge. That's why we usually don't talk about this. Yeah, so we're gonna skip this because it's not lost. Okay, and now we then move over to high and low level language. So I don't think this is a very big topic because we only have to know three parts, and this is the table that you need to know. Okay, so this is the best table that you need to know for this entire topic. So compiler will translate a high-level language to machine code. Interpreter will execute a high-level language, one statement at a time, like Python. Assembler will translate low-level language to machine code. So compiler and assembler both to machine code, but compiler high-level language to machine code, assembler low-level language to machine code. Compiler would have is an exe file of the machine code which is produced. Interpreter, no executable file is produced. Assembler, an executable file is produced. For compiler, one high-level language statement can be translated into several machine codes. Interpreter, one high-level language program may require several machine code instructions to be executed. One low-level language statement is usually translated into one machine code instruction, and yeah, so on and so forth. Then compiled programs are used without the compiler. Interpreter programs cannot be used without the interpreter. Assembled programs can be used without the assembler. So you can see compiler and assembler are quite similar because they all are dealing with converting to machine code. Compiled program is usually distributed for general use. Interpreter is often used when a program is being developed, and finally, assembler is used for general use. Again, this one is going to come into paper 2. That's why I'm not going to have a look at this right now. So yeah, that is that. Now we're going to have a break, and I'm going to be setting up a previous video that I've done. So I'm going to be playing that. But again, that's what we're going to do. So just a 5-minute break, and then I'm going to play the video. Hey guys, welcome back to another video. Today we're going to be looking at security and ethics in the computer science syllabus. So further ado, let's begin. So in this video, you'll be looking at how we can keep data safe, and if it's not safe, what are the actions that we can do. We'll also be looking at how we can keep the data, like basically the preventions and also the causes of data, or when keeping data safe. We'll also be looking at the uses of passwords, firewalls, proxy servers, SSL, TLS, and encryption. So those are basically all terms of how we can prevent identity theft or when data being stolen. We'll also be looking at some risks by phishing, farming, hacking, the common ways of how data is stolen, and we'll also be looking at some security safeguards when carrying out online transactions in computer ethics. Before we start this video, the current source where I'm reading all of these notes will be down in the description. It is an IGCSE textbook and can be solely trusted. So let's begin with the introduction. Keeping data safe is very important, and we all know nowadays everything has gone online. So keeping data safe is very important because nowadays retrieving data from somewhere is becoming so easily because people are not that careful. So much data is stolen from your relatives or an individual that's using a computer, and therefore we're learning this chapter to ensure that our data is safe at all costs. Now, data can be corrupted or deleted either through accidental damage or through a malicious act. We'll look at the malicious acts and how we can also prevent these malicious acts as we go on in this video. And there are many ways to keep the data safe, and so in this video we will look at the different ways we can keep this safe, and we'll also look at the causes of these identity thefts. Like example, if someone does this malicious act, what will happen to your computer, or what can they gain, and what's the best solution to do at that appropriate time. So let's begin with security and data integrity. So whether a user is working on an offline computer or a computer connected to the internet, keeping data is very important. So again, keeping look at this, it's saying even offline. So some people think that you can only uh, get data stolen if your computer is connected to the Wi-Fi, but that's wrong, because data can also be stolen when it's offline, and we look at the ways how offline, online, and all sorts of stuff like that. Data is threatened by the malicious software, hackers, or accidental damage, and this section covers a number of different security risks and considers ways to overcome or minimize them. Sorry about that. Okay, so we're going to be looking at the different security risks and how we can overcome them with just simple precautions, and it can help so much, can reduce a lot of stress, either if it's your bank account detail or personal information that's stolen. So if you just do these small tasks, you can basically prevent so much headache and stress and all of that by just doing simple tasks that can save a lot of data from your computer, because nowadays everyone is using computers and hackers are just getting a better way to steal data, and hackers are just becoming better and better, and therefore we ourselves have to also be aware of everything, and therefore we're learning this chapter to ensure we can reduce the security risk and be aware of what we're doing in the computer. So let's begin. We're going to be starting with hacking. So we're going to be looking at the different security threats or aspects when someone steals data from your computer. So we're going to start with hacking, and we all know the word hacking comes in so many movies, series, and everyone talks about hacking. But in a computer science term, hacking is the gaining of illegal access to a computer system. So in a computer science exam, for example, it tells you to mention or tells you to state what is hacking. You simply have to say this is the act of gaining illegal access to a computer system. And the keyword here is illegal access. So when you're writing this in your exam, they will be looking at gaining of illegal access. And then the second mark would be to a computer system, because hacking, right now, we're looking at it in terms of a computer and how data is stolen from a computer system. And therefore, hacking is basically the act of gaining illegal access to a computer system. So hacking, let's look at some of the causes, let's look at some of the preventions that we can do in to reduce the impact of hacking. So the first cause of hacking, when someone performs hacking, what happens? So hacking will often lead to identity theft or gaining personal information. Throughout this video, I've been saying identity theft. That simply means that I can get information about you, maybe your address, where you stay, or maybe some family, relative details, all those information that is personal and not meant to be told to anyone else, like bank details and so on and so forth. Those are basically called personal information, and identity theft is basically that, okay, when someone is getting to know you, that is to be personal. So someone should not know about it, but with hacking, they're able to get those informations. The next one is that data can be deleted, changed, or corrupted. Now, in your computer, we have data, and we've done that in the input-output devices, storage devices. Since if you've been doing computer science, ICT, you've been knowing that data is always stored. We have data, we have information. Data is basically stored in the computer. And with hacking, they give or they get an opportunity to steal that data from your computer. They can steal it, they can change it, they can also delete, they can wipe out the entire data of the computer, and they can also corrupt the data. And when you say corrupt the data, that also simply means to change the data, or when corrupting the data, basically adding something to it which can cause it to corrupt. So that's what happens when hacking occurs. So when someone hacks, you have the following impacts to your computer. Now let's look at a way on how we can prevent the hacking. Let's see how we can prevent hacking. Number one is firewalls, and I think you've heard about firewalls. It's a very common term in computer science, but I think we'll look at firewalls later on this video. We'll look at it more in depth on what is firewalls, how firewalls help. But for now, you just need to know that we use firewalls for hacking. Secondly, is that we use strong passwords and user IDs. Using strong passwords can be very important because number one, that can make the hacker or make hacking more harder when you have a strong password because it's harder to get access to the computer system, and therefore use strong passwords and user IDs to make it much more harder for the hacker to gain access. The next one is using the anti-hacking software. Anti-hacking software basically gives you an alert that maybe someone is trying to get access to your computer, and you can then take action according to what that software tells you to do. So basically, anti-hacking software, or any software in general, will basically alert you, or some of the softwares can also um, do the action and give you like a notification saying that someone is trying to give you access. We have done so forth, so we've done this. Okay, so that's what we say by software. So we've looked at the preventions, we've looked at the causes, we've looked at what hacking is, and now let's look at the difference between cracking and hacking. Okay, so this can be an exam question too, which can say what is the difference between hacking and cracking. So we said that hacking is breaking into a computer system to steal personal data without the owner's consent. Okay, but the owner doesn't know, or the user doesn't know that they're getting hacked. But for cracking, it's when someone edits a program source code for a purpose. Okay, and this can be a purpose as in to see what has happened, or uh, to see if the code is altered, or to see if a software is legitimate, and that's where we use a cracker. So a cracker is aware, so the user is aware of what they're doing, because a cracker will see if their software is indeed corrupted, changed, or deleted. But for hacking, the user does not know. So that's the difference between hacking and cracking. Let's move on to the next one. We say viruses. What is a virus now? This is not the ongoing viruses like the COVID, but the viruses in a computer system is simply a code that replicates into the computer system with an intention of deleting, corrupting, or can cause the computer to malfunction. So viruses indeed are just like the real life, where they spread. So does it in a computer system. Basically, it replicates itself with an intention of deleting or corrupting files, just like the real life viruses. Let's have a look at the causes and the preventions. When looking at the causes, we have can cause the computer to crash, stop functioning normally, or become unresponsive. Now, usually how a computer can be slow is one of the side effects of viruses. Okay, when your computer system is slowing down, or is very slow as day progresses, that means that there's a virus in. It's not a must that it's a virus, but you should look into it. But sometimes if your computer is slow, it can be because of memory, maybe it's full. But one of the effects is that if your computer system is getting slower, it is because of viruses. The next one is it can delete files and data. As we said in the definition, it replicates itself in an intention to delete or change data or corrupting the files. So these are just some these are some causes that are done by the virus. Let's have a look at the preventions now. With the preventions, we have user antivirus software, and just like the other, like hacking with the anti-hacking software, it's the same thing. It's the same way the antivirus software works. Basically, it gives you a notification that there's a virus, do the necessary actions to prevent it. The next one is don't use softwares from unknown sources. Now, usually nowadays, so many people are getting a lot of information from the internet because it's free. For example, movies, which is the best example you can give. Now, many people nowadays search for movies online, and they go to websites, and those websites actually install viruses into your computer, which replicates itself to delete data, and you will not notice this. until it's very hard to notice a virus unless you have antivirus softwares, or you can notice your computer being slow, and therefore try to avoid visiting websites like that, and usually only visit secure websites. And later on we'll see on how to determine if a website is secure. We look at ways to know that this website is secure and it's good to enter it. Now, usually, if you use antivirus software basically also um, gives you a notification that this website is harmful and therefore don't use it. Okay, so that can also be a plus point of using an antivirus software. And finally, the next prevention is be careful when opening emails. So many people have spam emails, but nowadays Google emails are becoming more smarter. They are categorizing each email like spam and all. But be careful when opening emails attachments from unknown senders. So if you're not aware about them, avoid opening them. Okay, let's move on to the next security threat, which is phishing. So we have phishing, farming, and phishing and farming. Okay, so let's look at phishing and let's look at farming. So with looking at phishing, this is when the creator sends a legitimate looking email, and as soon as the user clicks on the link, it is redirected to a fake bogus website, and this fake bogus website is therefore then stealing data or helps to gain a bank account details or so forth, basically personal data. So let's look at the causes. The first one is that once when the user clicks on the email or the email when it's redirected to the website, this can allow the user, whoever is behind this hacking or behind the phishing, will basically be able to gain the personal data such as the bank account details, family members, numbers of users of the computer, and so on, so forth. Okay, the next cause is that this can lead to fraud or identity theft. Again, most of these uh, security threats are leading to identity theft, if you've noticed. So why would someone want identity theft? Why would someone want to know where you live? Now, this could be a threat, okay? Okay, you can email or you can message them saying that I have your address, send me this amount of money, or else I will sort of do this. Okay, and therefore the user gets scared and gives them money. This is what we call identity theft. So let's look at the preventions. The preventions is use an ISPS filter out the phishing emails. As I told you now, uh, internet is also becoming smarter, and therefore we are categorizing different emails, and this can basically reduce the fraud emails, can reduce these phishing emails aside, so you don't even open it. So we use the ISPS filters to filter out all of these phishing emails. The next prevention is that the user should always be cautious when opening emails or attachments, just like the previous one with viruses. It's the same thing. Always be cautious. And most of these hacking theft, or most of these hacking uh, or what we say security threats, you always have to be cautious. You have to always be aware of what you're doing in the computer system, and therefore most of these people target the old people because they're not as uh, informated, I would say, or that they're not with information. They don't have enough information on how to use the computer, and therefore sometimes they get lost, and therefore it's a very easy target to get whatever they want. uh, Either it can be personal data or money, bank account details, anything. Okay, so therefore they target the appropriate age or appropriate population for an easy task. But therefore, I think everyone needs to be aware of what they're doing. And let's move on actually, and let's move on to farming. So phishing and farming. Farming is a malicious code that is installed on a user's hard drive or on the web server, and this code will redirect to a fake bogus website without their knowledge. So you can see phishing and farming both redirect to a fake bogus website, but the difference is that farming is a malicious code, while phishing is basically when they send a legitimate looking email, which then redirects to a fake bogus website. So let's look at the causes of the farming, and the causes are the creator of the malicious code can gain personal data just like the others, and this can lead to identity theft just like the others again. The next one is that some of the anti-spyware software can be identified. So again, we use the anti-spyware. Again, for the preventions for this, you use ISPS. There's no software to reduce this. This one you just be aware. With this one, we have antivirus, we have anti-hacking. So we have quite some softwares nowadays to help us. So this one we can use the anti-spyware. Okay, and the user should always be alert and look for clues that they're being redirected to another website. Let's move on to war driving. So war driving is simply the gaining or is basically when you locate and use wireless internet connections illegally without someone knowing. So if I use your internet connection without you knowing, that's basically called war driving. The causes would be that you can steal a user's internet time, and this basically means that if I steal your user's internet time, if I steal your internet time, that will just reduce the internet speed. And if you've noticed that if many of your family members use the Wi-Fi will reduce. Now, me using your Wi-Fi will be another member, and therefore slowing down the speed of the Wi-Fi, which can basically steal the user's internet time. The next one is that it is possible to hack into the wireless network and steal the user's passwords and many other personal details. So that's called war driving, and that's the causes of war driving. How we can prevent it is that we use a wide equivalent privacy, the WEP encryption. Okay, we look at encryption again later on in the videos that will come up, and we also use firewalls that helps us to prevent the outsiders to gain access. Finally, let's move on to spyware and then cookies, and then in the next video we will be looking at the loss of data and data corruption. Okay, so we will split this into two parts. So the part one will only be looking at the different identity thefts or the different security threats. So let's look at spyware. Previously, when we talked about farming, we looked at anti-spyware. So it should be something related to that, but it is not. So you think that the software means anti-spyware. It does not mean like that. Okay, so what we say by spyware is basically when we gather information by monitoring key presses on the user's keyboard, and then the information is sent back to the person who sent the software. So this is basically we monitor what, or when someone monitors what you're typing to gain information. And why would someone want to know what you're typing? Now, for example, if you visit a bank website, okay, and you input your password with your keyboard, this will basically send it to the user who sent the spyware and can therefore get to know your bank account details and then can get money out of that. So let's look at the causes of this. Again, spyware is basically gathering information by monitoring key presses on the user's keyboard, and then the information is sent back to the original originator, we can say. Okay, so when looking at the causes, gives the originator access to all data entered using a keyboard on the user's computer. Of course, that's in the definition too. And the software is able to install other spywares, read cookie data, and also change the user's default web browser. So this is basically getting information from the computer. How we can prevent this is number one, use an anti-spyware software. Again, gives you an alert that someone is trying to basically monitor your key presses. The next one is that the user should always be alert, look for clues. And thirdly is that when you're inputting any password in a website, use your mouse. Try use your mouse because they cannot monitor the mouse. Finally, let's move on to cookies. A cookie is not a security threat, but basically stores the data when you use a web browser. Okay, so let's look at this definition. A cookie is a packet of information that is sent by a web server to the web browser. Okay, sent by the web server to the web browser, and cookies are generated each time the user visits the website. And normally nowadays, if you go to a website, it will say that this website uses cookies, accept and deny and stuff like that. Okay, so usually most people just click on accept and without even knowing what they're doing. So cookies are basically a packet of information that is collecting whenever you're using a website. So again, it's saying a message is frequently displayed, saying that cookies are required to access the website, and basically you accept. And every time a user visits the website, the cookies will have collected the key information and store it in their web browser. So what this means that when I go and log into one of the websites, automatically maybe they log me in. And this is done because of the cookies. They have just collected the key information about the user. So whenever we go to the same website, it will store the data. So here's a good definition. Cookies aren't programs, but are simply pieces of data. It is not a security threat. So whenever they ask you, is cookies a security threat? And then exam question, they are not a security threat, but simply programs that store data. And they can't actually perform any operations, but just allows detection of web pages viewed by the user, and basically just stores and gathers information from the user when using the website, and does not contain any personal information. It's not stealing any personal information. So there you go. We looked at cookies, we looked at spyware, we looked at war driving, farming, phishing, viruses, hacking, and we looked at some of the introduction to how some data can be stolen. In the next video. Okay, guys, so that concludes the live stream. Thank you so much for watching. This chapters on your screen is what we covered. Again, if you want to practice on some extra questions, down in the description, I've put about 3 videos, past paper questions, where I go and have walkthrough of each of the past paper question on these chapters. So we have done these 8 chapters. So hopefully you enjoyed this long live stream. I enjoyed it. So hopefully you guys did. Thank you for watching it. And if you made it all the way, I assure you, you will do much better in the theory papers, because this video is very thorough of every 8 topics of every chapter. It's very thorough. So thank you for watching.